Moving on to one of the final parts of the assignment, we have an example problem up here to get us started with these 3 questions, and then we have 3 more practice problems that follow this sort of pattern. In our example, we were given our volume, our length, and our volume, width, and height, but our length was kept blank. This is similar to one of the problems that we did on the last page, and similar to one of the problems on the supplemental activity that was posted up on Tuesday. For number 1, it asks what operation was used on the equation 255 L times 20 to find the length L. They're referring to this step right here. They're referring to what did we do in that step. If you recall from our algebra section, we would have done something known as isolating the variable, or using an inverse operation to eliminate the 20 and put it on the other side. This currently says L times 20. The opposite of multiplying by 20 is dividing by 20. When you divide by 20, you are effectively removing it from the side that we were multiplying by 20. Just think about what L could have been if L wound up being 10. And I said 10 times 20 divided by 20. Was there any point in that 20 being there in the first place? Not really. It might as well have just been crossed out. We are dividing both sides by 20, and that's kind of the short answer. What operation is used? Division. We needed the inverse operation for multiplication. For number 2, another block has a volume of 180 cubic inches. The area of the base is 72 square inches. What is the height of the block? And they were very kind and gave us the formula, even though we should have remembered it from the last page. So, we've got volume equals base times height. We have our volume, 180, and we have our base, which is 72. We do not have our height. Much like in our example, we are just going to do the inverse operation, and we will divide both sides by 72. That will eliminate the 72 on this side, leaving us with a height of whatever 180 divided by 72 will be. .5, also known as 2 1/2. And that is going to be inches. We are not going to say inches cubed. Much like this, we are just finding one side, not the entire volume. So they will not be cubic inches. Number 3, a third block that is 5 inches high and has a volume of 165 cubic inches. The width is 5.5 inches. Is the length the smallest dimension? Explain. Well, we can go ahead and actually write this out and find out for sure. Volume will be length times width times height. We can replace our height and our width. We do not have our length, but our width is going to be 5.5, and my height will be 5. 5.5 times 5 will be 27.5 times L. So volume, which I should replace by now as 165, will equal 27.5 times L. Now the opposite of multiplying, as we've done the past 2 times, is dividing. So we're simply going to divide both sides by 27.5. So 165 divided by 27.5 gives me an answer of 6 inches. So my length equals 6 inches. So is the length the smallest dimension? No. Please see attached work as proof. There we go. In my book, this is far better of an explanation than you could actually provide using words. I would much rather see your work and see your process of solving it, rather than just hearing you tell me, oh, I solved it by doing what you taught me. Yeah, great, I'm glad about that, but can you prove it? Can you show me the work? Moving right along to number 4. The owner of a gift shop keeps holiday decorations in a rectangular box that has a volume of 30 cubic feet. The length of the box is 4 feet and the height is 2.5 feet. What is the width of the box? Draw a picture and label the dimensions. Okay. So we have a rectangular box. It has a length of 4. We don't have the width. So we can't really draw an accurate picture until we know exactly what those dimensions were. Let's go ahead and work it out. We know volume is length, width, and height. We know the volume is 30. We know the length is 4. And we know that the height is 2.5. Let's go ahead and solve this, shall we? We have 4 times 2.5. We can go ahead and combine those two and go out of order using the commutative property. So 4 times 2.5 equals 10. And we know that we can divide both sides by 10, which gives me a width of 3. So my width is 3. We've got our solution. Now we must draw our box. It appears that the length is going to be the largest number with 4. The height is going to be the shortest with 2.5. And the width is going to be between them with 3. So we have length, which equals 4, height, which equals 2.5, width, which equals 3. That's number 4. For number 5, Vicky and Jim have a lawn care business. Jim keeps equipment in a shed that has a volume of 66 cubic feet. Looks like we'll be using this. The length is 5 feet, the width is 2 1/5 feet. Vicky keeps equipment in another shed that has a volume of 63 feet. The length of that shed is 4 and the width is 2 1/4. They want to store a new lawnmower in the taller shed. Which shed should they use? So they know the volume, they know the length and height, but they have never bothered to measure the height of their shed. So for both of them, we've got Jim, we've got Vicky. Both of them will be using volume equals length, width, and height. Jim, his shed is 66 cubic feet. The length is 5, and the width is 2 1/5. For Vicky, her total volume is 63 cubic feet. She has a height or a width of 4, length of 4, and a width of 2 1/4. We can go ahead and start by combining those like terms. We can combine 5 times 2 1/3 to get 35 thirds over h, or times h. And for Vicky, we have 4 times 2 1/4, which is 9. We're going to go ahead and start with Vicky, because that is a bit more straightforward. Divide both sides by 9, and Vicky's shed has a height of 7 feet. As for Jim, his shed, we would say that we are dividing both sides by 35 thirds. However, in practice, we are going to do keep, change, flip, and we are going to multiply by 3 over 35ths. And that will do functionally the same thing. So 3 over 35 times 66. So we have 198 over 35. That's not really good for comparing with 7 feet. So we'll use that trick we saw in the last video about converting from an improper fraction to a mixed number. Step 1, the second button. Step 2, look for an icon that shows a regular fraction on one side and a mixed number on the other side. Right here. That is attached to this button down here. With the second button pushed, we can push this button and it will convert to a mixed number for us. So for Jim, his height for his shed is 5 and 23/35 of a foot. So, which shed will they use? They want to store the shed in the taller shed. So Vicky's shed is taller. That would be our answer. Since Vicky's shed is taller, that is the shed they will use. For number 6, it says the base of a rectangular prism is a square. The height of the prism is half the length of one edge of the base. The volume is 13.5 cubic units. What are the dimensions of the prism? Ooh, this one is going to be interesting. So we have volume is going to equal, let's see, so the base is going to be a square. So the base, let's start with area of the base and the height. And the height is half the length of one edge of the base. This is going to be a rather interesting problem. For starters, for this problem, we're going to replace my volume with 13.5. That will equal a base times a height. Now, we know that the height is going to be half of one of the lengths. So we know length equals width. They are going to be the same. 13.5 equals length times width times the height. And we know that length and width have to be the same. And we know whenever we multiply them, it has to be less than 13.5. Because naturally, we still have to multiply by h. Let's assume that length and width are both 2. This was 2 and this was 2, that would be 2 times 2 is 4, times half of 2 is 1. So that would be 4, times 1 for the height, since it is half of one of the lengths. That would just equal 4, which is too small, so it is not 2. Fortunately, there are not very many options. The next choice is 3. Well, 3 times 3 equals 9. 9 times half of 3. Half of 3 is going to be 1.5. And if you were to try that out, 3 times 1.5, you get 13.5 without too much strain or effort. The length is equal to 3 cubic units, or 3 units. The width is also equal to 3 units. And the height is equal to 1.5 units. And that is all for this page, which is the third regular page of the assignments that were given on March 13th through the 20th. See you later.